Yo guys, hold up. Right now we're gonna go through a question which came in the 2025 GCE ECZ paper. Okay, the question reads that figure 6.1 shows a ray of light which is incident from air into an optic fiber which is made out of glass and its refractive index is 1.5. Next, okay, the calculate the value for angle I, which is the angle right here. So yeah, now this is where we need to get kind of involved in with principles, and we need to use Snell's rule or Snell's law. So Snell's law states that the refractive index of any material is equal to, so we can say Snell's law. So that means the refractive index, this figure, which looks kind of like that, it's kind of an eta, but yeah, kind of like an N. So here we're saying that the refractive index of glass as a ray of light moves from air is equal to sine I divided by sine R. So what we're finding here is the absolute refractive index. So whenever the ray is moving from air into another medium, that's the absolute, or from a vacuum to another medium, we call that the absolute refractive index. But there are certain instances where maybe we might have glass, water, and then they tell you to calculate the refractive index. There you need to use the principle of relative refractive indices, but in this case we're not talking about that. So here we're finding the refractive index as the ray of light moves from air to glass, which is the refractive index of the glass. So what we need to do here, we just need to substitute sine R and the refractive index to give us sine I. So sine I is equal to just multiplied by the corresponding, which is giving us the refractive index of glass multiplied by sine R. So here we can just say that I is equal to sine inverse of, so what's this here, right here? We could tell from the question that that was 1.5, and then sine R, which is the angle that you have been given, which is sine 34, right? Then if you punch that into a calculator, you're going to, that's equal to 65 degrees. And then for the